Before we do the implementation of the segmentation, first we will go through the deep learning models for segmentation so that you have the conceptual idea about these deep learning architectures, and later on we will implement these deep learning models for segmentation in Python and PyTorch. Let's have a look at the pyramid scene parsing network for segmentation. This network is also known as PSPNet. PSPNet was proposed in the paper Pyramid Scene Parsing Network published in Proceedings of the IEEE Conference on Computer Vision and Pattern Recognition. So if you want to read in detail, please go through this research paper. PSPNet is a fully convolution neural network for image semantic segmentation. It consists of a pyramid pooling module to exploit the local and global context information. PSPNet performed the segmentation on Pascal and Cityscape's benchmark datasets. In PSPNet, first a feature map is extracted from the last convolutional layer of the convolution neural network that is fed to the pyramid pooling module in order to harvest different pooling pyramids. Finally, convolutional layer is applied to obtain the pixel-wise prediction. PSPNet won the first place on ImageNet Scene Parsing Challenge 2016 on Pascal and Cityscape's benchmark dataset segmentation. Scene parsing is challenging for unrestricted open vocabulary and diverse scenes. In this paper, they exploited the capability of global context information by different region-based context aggregation through the pyramid pooling module together with the proposed pyramid scene parsing network. The global prior representation is effective to produce good quality results on the scene parsing task, while PSPNet provides a superior framework for pixel-level prediction. The proposed approach achieves state-of-the-art performance on various datasets. So here is the PSPNet architecture. So consider this input image. First, a CNN is used to get the feature map of the last convolution layer. Here you can see the feature map. This CNN architecture can be a ResNet or VGG that can be used to get the feature map of the last convolution layer. Then you can see the pyramid pooling module. This pyramid parsing module is applied to harvest different subregion representations followed by upsampling and concatenation layers to form a final feature representation. Here you can see the different subregions that are obtained after applying the pooling layer, and then upsampling and concatenation layers are applied to get the final features. Finally, the features are fed into a convolution layer to get the final pixel-wise prediction. Here you can see the convolution layer is applied, and here is the pixel-wise prediction of this input image. The pyramid pooling module fuses features under 4 different pyramid scales. The coarsest level highlighted in red is global pooling to generate a single bin output. Then the following pyramid level separates the feature map into different subregions and forms a pooled representation for different locations. The output of different levels in the pyramid pooling module contains the feature map with varied sizes. To maintain the weight of global feature, they use 1x1 convolution layer after each pyramid level to reduce the dimension of context information to 1 by n of the original one, then directly upsample the low dimensional feature maps to get the same size feature as the original feature map via bilinear interpolation. Finally, different levels of features are concatenated as the final pyramid pooling global feature. Note that the number of pyramid levels and size of each level can be modified. They are related to the size of the feature map that is fed into the pyramid pooling layer. The structure abstracts different subregions by adopting various size pooling kernels in a few strides. Thus, the multi-stage kernel should maintain a reasonable gap in representation. The pyramid pooling module is a 4-level with bin sizes of 1x1, 2x2, 3x3 and 6x6 respectively. For the pooling operation, you can perform the max pooling or the average pooling. Here you can see the PSPNet results visualization. First column contains the original image, second column contains the ground truth, and the third column contains the results obtained by the PSPNet. So you can see the PSPNet obtain the competitive results as compared to the ground truth.